Hello, Assalamualaikum. My name is Shahrul Nizam bin SABRIE, metric number D 2098. We are from group 6 and today we are going to present about transform circuit question 2 for our project assignment. Okay, for the introduction, the inverse Laplace transform of a function fs in mathematics is the piecewise continuous and exponentially restricted real function with the property LF equals to LFT equals to f, where L is the Laplace transform. If a function fs possesses the inverse Laplace transform ft, then ft may be uniquely determined, considering functions which differ from each other only on a point set having Lebesgue measure 0 as the same. This is known as the Lurch theorem, which was first shown in 1903 by Matthias Lurch. The Laplace transform and its inverse have a number of properties that make it useful in analyzing linear dynamical systems.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad HAKIMI bin ZARAWI. My meter number is DE20011. So here I will explain about the comparison discussion, which is from simulation, and comparison which is from manual calculation. Okay, for the during simulation in the MATLAB, the circuit that we done for 5 exponent negative t and 15 exponent negative t is the same circuit, which is the circuit we does not change. And for the simulation that we're doing, the result for the 5 exponent negative t that we get is 1000 volt, which is produced on VOT. And for the manual calculation, we also get 1000 volt, which is same as the simulation. The 1000 volt is we get from the partial fraction formula. Okay, and for the graph is showing is 1000 volt, which is from 0 to 10,000 at the 5 second, which is the graph is rise from 0 to 10,000 in the 5 second. And for the next one is 15 exponent negative t. The value VOT that we obtain is 10,000 volt, which is also same as the manual calculation. And in the graph shown that we can get the graph from 0 to 10,000 in 5 seconds, which is the 0. And at the 5 second, the graph is showing mass, which is 10,000 volt, and it will maintain 10,000 at the 5 second. And for the manual calculation, we also can get the 10,000 volt, which is same as the simulation that we doing simulation. And with this, we can prove that simulation and the manual calculation is same. The result is same, and we can prove that manual calculation also can be used for the replace the simulation. That's all for me.
Assalamualaikum warahmatullahi wabarakatuh. My name is MUHAMAD AIZIL FIKRI RASLAN with the metric number of DE2041. So today I want to explain about the circuit, which is the question of number 2. So basically this is the figure of the circuit with the value of IST, which is equal to 5e to the power of negative t ut ampere. So the value of the resistor is 40 ohm and the value of the capacitance, which is 20 millifarad. So for question A, we need to find the value of V output T of the circuit. For question B, we need to find if the value of IST is increasing to 50 e to the power of negative t ut ampere. And then we need to also determine the V output of the circuit. And last but not least, we need to compare the result from A and B and what happened when the supply current increases, and explain and also write the conclusion for the result C. So I want to proceed and present for the manual calculation. So this is the manual calculation for time domain and frequency domain. So the question given is in time domain, we need to change the circuit to frequency domain, which is, as we can see here, the value of capacitor, which is 20 millifarad, the value of resistor is 40 ohm, and value of ISC, which is 5 e to the power of negative t ut ampere. So when we change to frequency domain, we found out that the value of resistor is actually the same, which is 40, but the value for the capacitor, the formula is 1 over SC, which is we put in the formula 1 over S multiplied by 1 over 20 milli equal to 1 over 50S, which is we can conclude that the value of the capacitor when in frequency domain, which is 50 per S, and also the value for the ISC, we change the value to frequency domain, we get 5 over S plus 1. And then we can see here for the S domain, the formula for the output voltage is 1 over C divided by S plus 1 over RC multiplied by I as frequency domain. Then we put 1 over 20 milli, the value of C, divided by S plus 1 over 40, value R, resistor, multiplied by 20 milli, and multiplied by 5 over S plus 1, which is the value of I as frequency domain. And we can see the value of the circuit for V output, we get 250 divided by S plus 1.25 and S plus 1. So where we get the value of 1.25 is from here, 5 over 4 is equal to 1.25. So for the next, we apply the partial fraction formula, which is 250 divided by S plus 1.25 multiplied by S plus 1 equal to the value of S plus 1.25 is value of A, and then S plus 1 is value of B. So we apply the partial fraction. When A equal to negative 1.25, we get 250 equal to A. We change the value of S here. We multiply A with S plus 1 and B with S plus 1.25. So A multiplied by negative 1.25 plus 1, and here the value of B equal to 0 because negative 1.25 plus 1.25 is equal to 0, and then the value of A equal to 250 multiplied by 4 and divide by negative 1, we get the negative 1000. So to find B, we change the value of B equal to negative 1 when S equal to negative 1. So the value of 250 equal to A, which is negative 1 plus 1 equal to 0, and B negative 1 plus 1.25 equal to 1 over 4B. So we get the value of B, which is 4 times 250 divided by 1, which is we get 1000 for B. So for the V out of frequency domain, we get 250 divided by S plus 1.25, S plus 1 equal to this the value of A. We put that we get from here in here, negative 1000 over s plus 1.25 plus 1000 per s plus 1. And then last but not least, performing the inverse Laplace transform yields the time domain representation, where we change the value of frequency domain from here to time domain. So we get from the table V output in time domain equal to 1000 multiplied by e to the power of negative 1.25t equal e negative t ut volt. And then for the question number 2, which is B, when the value of IST equal to 50 e negative t ut ampere. So also the same as question A, we change the value of 50 e to the power of negative t ut into frequency domain, where we get after we change the value is 50 over s plus 1. And then as we look here, for the S domain, the formula for the output voltage is actually also the same as question A. So we put the value 1 over C S plus 1 over RC. We put the value of RC, but multiply with the new value of IS frequency domain, which is 50 over S plus 1. So after we calculate the result, we get 2500 divided by S plus 1.25 and S plus 1. And then we can see here, also apply partial fraction. Actually the same, 2500 equal to A over S plus 125 and plus B over S plus 1. So we change the value of S of A equal to negative 1.25, and then 2500 equal to A, negative 1.25 plus 1 is equal to negative 1 over 4, and then the value of B, we can conclude the value of B is 0, and then the value of A we get is 4 multiplied by 2500 and then divide by negative 1, which we get is negative 10,000. So for the value B, we change the value of S to the negative 1. So 2500 equal to 0, which is the value of A equal to 0, and plus B multiplied by negative 1 plus 1.25. So we get 1 over 4B equal to 2500. So the value of B equal to 4 multiplied by 2500 divided by 1, which we get the value of B is 10,000. So we write the formula given and put the value of A and B in this formula. So 2500 per S plus 1.25 S plus 1 equal to, this is the value of A, negative 10,000 over S plus 1.25 plus this is the value of B, 10,000 divided by S plus 1. And then last but not least, we need to performing the inverse Laplace transform yields the time domain representation, which is we can see from the table. We get V out for time domain equal to 10,000 multiplied by e to the power of negative 1.25t minus e to the power negative t ut volt. So my part for A and B, this is the manual calculation. We go through for WALIUDDIN for the simulation and for the question C. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad WALIUDDIN bin Ahmad Shukeri. My matrix number is DE 2086. Now I'm going to present for the simulation part. And so this is our circuit according to the question that has been given. So this is the RC circuit with DC current source. So this is the current source. So the value for the resistor is 40 ohm and the capacitor is 20 millifarad. So in this for the simulation, I use the MATLAB in yeah, I use the MATLAB for the simscape. So uh, after we connect to each other, and then this is the solver configuration. This is important part for this circuit in this MATLAB because it give the parameter the best value, so the circuit will be function. So the voltage sensor will be connected to the display and the scope for the graph. So for the first data that has been given, which is for 5 exponent negative t ampere. So we need to find the voltage output at here at the capacitor BOT. So we put the value which is the 5 exponent 1 per 2. So we assume the negative t is 1 over 2. So after we run, this is what we got, which is 999.9962. So this answer so this value for the simulation is similar to our manual calculation, which is we got for first one, we got the value of VOT is 1000 volt. So after that, we looked at the graph, which is the voltage versus time. So we can see here the voltage will rise until it reaches the 1000 volt, and then it will be the steady state. Next, I will change the value into the 50 ampere. So I will run. So the value VOT from the simulation is 999.9627. So this is also similar to our manual calculation for VOT, which is we got 10,000 for VOT. Then this is the graph for the second one. So same voltage versus time. So we can see the graph will rise from 0, and then it will reach for 10,000 volt, and then at the 5 minute or second, it will be in a steady state. So that's all from me. Thank you.
In conclusion, the inverse Laplace transform is very useful to know for the purpose of designing a filter, and there are many ways in which to calculate it, drawing from many disparate areas of mathematics. All nevertheless assists the user in reaching the desired time domain signal that can be synthesized in hardware or either software for implementation in a real-world filter.